Okay, so this picture captures what's happening in loop 5. Matrix C is partitioned into very wide panels. Remember that NB is something like, let's see, in the makefile I've set it at 2016, but in practice actually it probably should be even larger. And what does that mean? That means that if we go and we, in a round-robin fashion, assign the panels of C and B to different threads to compute with, then the matrix must be very, very large before even more than one thread is being used. So that's a problem. Well, what does that mean? Well, it may mean that we may want to just go ahead and not use the block size to partition, and at least for smaller problems, simply partition C and B into equal parts. Okay. Now the next problem is that when we get to loop 4, we create these column panels of A and row panels of B, and this row panel was chosen to fit in the L3 cache, and that was actually the reason why we created the partitioning of C and B in loop 5, so that this particular panel is only of width NB. Now, by the time we get to this point, we will have actually, if we're using 4 threads, 4 of these happening simultaneously, which means that we end up with 4 of these panels sitting in a shared L3 cache simultaneously. So what that means is that we really want to go ahead and, at least for very large problem sizes, restrict this particular width of the panel of B to be the NB size divided by the number of threads, 4 in this example. Okay, so you need to take all of those things into account as you try to come up with a solution. So hopefully you now have enough of a hint that you can come up with your own solution. And in the solution to the exercise, you'll just see the implementation that I came up with.